Let's talk about equations with decimals. That's what we're looking at here. If you have an equation that has decimals, how do you work with those equations? Well, the good news is you work with them the same way you've worked with other equations. So in this case, x plus 1.25 is equal to 0.6. You subtract 1.25 from both sides. And now you use your principle that you learned for working with subtracting and adding decimals earlier. So if you have a situation like this, which is 0.6 minus 1.25, right? You could technically write that as negative 1.25 plus 0.6 like this. Remember the strategy where you put the 1.25 minus 0.6 and then you basically take care of what's inside the parentheses. So 1.25 minus 0.6, you have 5. This is going to go here. You have 12 minus 6, so 0.65, and then you apply that negative. So negative 0.65. So x is equal to negative 0.65. That is the same principle in terms of moving things to the right side of the equation. If whatever you do to the right, you have to do to the left. And then if it's an addition, then you subtract. If it was a subtraction, you add. That's what you do there. The next question, x divided by negative 0.35 is equal to 4.2. So you multiply both sides by negative 0.35 minus 0.35. You multiply both sides, and that's how you get rid of that. You have x is equal to, now you have 4.2 times 0.35, and that's 1.47. Oh, actually, they gave you that one already. I apologize. I was working out the details. And then you apply the negative because a negative times a positive is a negative. Sorry, I was working out the details. I should have used the other one they gave you, which is y over 0.37 is equal to negative 1.52. So you multiply both sides, right? This is a negative. Let's write this out clearly. Negative 1.52. So you multiply 0.37 on both sides, and that will get rid of it there. And then you just simplify this answer here, which would be 0.37 times 1.52. Of course, the negative stays, so it's negative 0.5624. So you use the same principle for solving equations you've learned through the course to add, subtract, multiply, divide. Let's look at another example. Negative 2.5z is equal to 1.4. You divide both sides by negative 2.5 in this case. And we get z is equal to, so you just have, again, with some of these, when you're doing them in chemistry and physics type problems, you are allowed to use a calculator. So if we're doing this one, we'll get negative 0.56 for that particular problem. So that's how we work with solving equations involved, with decimals. If we have a problem like negative 0.02u minus 3.2 is equal to negative 1.75, we add 3.2 to both sides, right? So we move that over to the other side, and then we divide both sides by 0.02. So negative 0.02u is equal to, so you have 3.2 minus 1.75. So we have 1.45, and we divide both sides by negative 0.02. And when we do that, we have 72.5 negative, right? Because the negative, positive divided by a negative is a negative. There's a principle that you learned earlier in the book called combining like terms. And all that happens with like terms is that if you have something like 2t plus 3t, that will become 5t if you're adding like terms. Like terms are variables in the same power and of the same type. So 2t plus 3t, these are like terms. But if you add 2t squared plus 3t, those are not like terms. They won't just add automatically like the other ones would. So that's the next part of what we have here. So we have a situation like negative 4.2 plus 3.6r minus 4.1r is equal to 1.86. The r's they're like terms, they can work together there. So 3.6 minus 4.1r, so that's basically negative 0.5r. this negative 4.2, we can add 4.2 to both sides of this equation. So that will become 606. So negative 0.5r is equal to 6.06, right? So 6.06 divided by 0.5, and that will give us negative 12.12. So that's how we work with adding like terms and then simplifying our answer. The next piece of this section is talking about, or the next section of this chapter is talking about the distributive property. Next piece we're looking at, the distributive property. Remember, when you talk about the distributive property, if you have t, u plus v, it will be equal to t times u plus t times v. So with the distributive property, whatever is outside can multiply with that which is inside. So we have a situation like negative 2.5 x minus 0.1 into x minus 2.3 is equal to 8.03. So the 0.1 will multiply, will distribute into each of those. So it'll be negative 2.5x minus 0.1x plus, so now you have 2.3 times 0.1. So that becomes 0.23 is equal to 8.03. The like terms will add. It'll become negative 2.6x plus 0.23 is equal to 8.03. We'll subtract 0.23 from both sides. So we have 0. This will become 7 and a 1, 8. So 7.8. So negative 2.6x is equal to 7.8. We'll divide both sides by negative 2.6. So you have 7.8 divided by 2.6, and that will give you negative 3. So that's how we simplify. We used the distributive property, and then we applied, the principles we've learned from solving equations. There are times that you'll be asked to approximate, round to the nearest tenth or round to the nearest hundredth. Just remember to use the same principle you learned before if you're asked to round. If you have questions on the rounding portion, let me know. There are applications in this section. I'm not as concerned about the word problems at this time. They're fun to do, but I would say doing number 1 to 57 odd is a good place to be. And then if you want to do the word problems, go ahead, for fun. You can look at some of the word problems. You can even look at like 79, 80, and 81. And then just for fun, just look at them and, see what the answer is after you try the problem. Or just see, how they explain it. I think you'll enjoy it. And then number 59 to 78, those are all word problems. I'm not as concerned about doing those, but just read the application section in your book. They explain clearly the same principles. Set up the variable dictionary, set up an equation, solve the equation, and then answer the question and look back. Those are very good steps you can take. So let me know if you have any questions. I will end with this word problem from the one next to example 9, and then we will see you in the next section. It says Eta's dog Eta's dog run is in the shape of a rectangle with area of 500 square feet. So this person is running, and the area they're covering is 500. Eta's dog run is in the shape of a rectangle with an area of 500 square feet. If the length of the run is 28 feet, so let's say this is 28 feet, they want to know what the width is. So if the length is 28 feet, what is the width? And the way to get that, they want to know to the nearest tenth of a foot, is to remember that the area of a rectangle is length times width. They've given us the area as 500 feet squared. They've given us the length as 28 feet, and we don't know what the width is. So we divide both sides by 28. So if you divide 500 by 28, you get 17.8571. They wanted it to the nearest tenth, so that becomes 17.9 feet. That would be the width of this particular one that we're working with. So, very good question. Adult tickets to the circus cost $12.25 a piece. If the club has $1,200 set aside for adult ticket purchase, How many adult tickets can they purchase? So this is the word problem next to example 10. If you have 1,200 divided by 12.25, you can buy 97 tickets, right? 97.9. I'm thinking the place would be kind to just let you have 98 tickets, but 97.96, very close to 98. So that's how you do that problem, and then they give you more practice, more opportunities to see, examples. So feel free to read those examples and try the problems, and let me know if you have any questions. Thank you.